Form 4, Chapter 4, Operation on Set. So we already learned introduction on set on Form 1, Chapter 11, and now we learn operation on set in Chapter 4. Okay, so in this chapter, actually we have two only. One is intersection of set, so the symbol is like this, and then later we will learn union on set on the next section. So so intersection, we have two set P and Q, and then the intersection between these two set is between P and Q. We use this symbol. Okay. Um. So all this we can just ignore. Okay. But the the intersection is the overlap part. Okay. So we look at the example number 1 here. Okay. So for example number 1, okay, it's given that the universal set is from 1 until 10. So the universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then P is odd number. Odd number 1, 3, 5, 7, 9. Okay, odd number is the number that not divisible by 2. So if we want to have a set of even number, then it's 2, 4, 6, 8, 10. Okay, and then Q, set Q is the prime number. So prime number we have 2, 3, 5, 7. Okay, prime number is the number that only divisible by 1 and itself. Okay, so if we, and then prime number start with 2. So if we have a 2 here, then we press shift factor is still 2, and then 3 equal, then the calculator still show the 3, then this is prime number. But if we have a 4 here and we have shift fact, then it can show something else, 2. That means the 4 is divisible by 2. 1, 2, 4. So this is not prime number. Okay, 5. 5 is prime number, so 5. And then 6. 6 is not prime number. Okay, 8 also not prime number. All even number except 2 are not prime number. Okay, 9 also not prime number. Okay, so 9 here not prime number. Okay, so R is multiple of 3, so we have the 3, 6, 9 here. Okay, so the list all the element of the following intersection of set. So if we want to have the P intersect Q, so P and Q 3, 5, 7 is the intersection. 3, both have 3, 5, both have 5, 7, both have 7. And then P intersect R, so 3 and then 9. Okay, 3 and 9. And next, if we want to find the Q intersect with R, so Q intersect with R, we have 3 only. Okay, so 3 only. Okay, the last one is the P intersect Q intersect R, which all three sets have 3. So this is okay. So state the number of P intersect Q. So we have 3 number, and then 2, 1, and 1. Okay, 3, 2, 1, 1. Okay, so this one we have the 3, 2, 1, 1. Okay, So because the intersection is a set, we must put a curly bracket here. How do you determine the intersection of two or more sets using Venn diagram? So we have P and Q. So this is the intersection between P, Q. So if the Q is the subset of P, then the intersection between P, Q will be the whole set Q. So this is P and R, intersection between P, R, and then all three P, Q, R, their intersection will be here. Okay, so we look at example number 2 here. Okay, so we look at the graph here. Okay, Venn diagram shows set J, K, and L such that universal set 1, 2, 3, 4, 5, 6, 7, 8 lists all elements of the following intersection of set. So if you want to find the intersection between J and K, okay, so okay, we want to have 4 here. 1, 2, 3, 4, 4. Okay. Ha. So the first one, J intersect with K. J and K, their intersection will be here. So will be 3 and 5. J and L. So J and L is here. Okay. So this will be the 5, 7, 9. K intersect with L. K and L. So we look at here. This is K. Okay. And then this is L. Okay. So the intersection between K and L will be this 5. So all three intersect will be 5 only. Okay. We know that the L is a subset of J. Then the L intersect with J will be the whole set F. Okay. It is given that set A is even number of dice. So we know that for dice, their outcome will have 1, 2, 3, 4, 5, 6 only. Okay, dice. So this one is dice. So we use it when we play game. Okay. So set A is the uh, number on a dice. Oh, number on the dice 1, 2, 3, 4, 5, 6. And then set B is even number 2, 4, 6. And then 6 set C is 7, 8, 9. So the A intersect with B. So A intersect with B 2, 4 only 6, 2, 4, 6. So we have the 2, 4, and 6. And then we want the B intersect with C is null set. Null set we can write as using this symbol, or we have a curly bracket and then without an element inside. And A intersect C also a empty set, null set. Okay. So we need to draw the Venn diagram to represent A, B, C and shade the region that represent each of the following: A intersect B and A, B intersect C. Okay, so over here, it is very obvious that the B is a subset of A. So the B is inside A here. So this is B, this is A, and then we have 2, 4, 6. So for element, we have to put a dot, okay, in front of it. Otherwise, it's the number of element inside. So 1, 3, 5. And then we have a set C here. Set C, we have the 7, 8 and 9. Okay, so this is the set. Okay, and over here they want A in the set B. A in the set B is here. Okay, and then B in the set C, not set. Okay, so we cannot do anything. Okay. Yes. Okay, so self practice 4.1a will be in the next video.